Hello, this is Sadbir. The topic of our discussion in this video tutorial is method of variation of parameters. Method of variation of parameter is used to solve second order non-homogeneous differential equation with forcing term g of t. The solution, the particular solution is given by this very long formula where you need to compute the fundamental set of solution y1 and y2, and also you need to compute the Wronxian of these two particular solution y1 and y2. These are the particular solution of homogeneous part of the differential equation. Also, one thing to be noticed, the coefficient of y double prime should be 1 in order to use this formula. Let's take a few examples and practice this method. So here I have a non-homogeneous differential equation with the forcing terms 3 consecant of t. So I will solve this differential equation in number of steps. In step number 1, I will solve the homogeneous part of the differential equation. So in order to do that, I need to find the auxiliary equation, which is m square plus 4 is equal to 0. That is my auxiliary equation. This is step number 1. The root of the auxiliary equation, as you can see, is 0 plus minus 2i. Therefore, the fundamental set of solution is gonna be cosine of 2t and sine of 2t, because e to the power 0 is 1. So this will be the fundamental set of solution. So once I have the fundamental set of solution, I will move to the step number 2, in which I will calculate the Wronxian. I will call this is a y1 and this is a y2. So you can choose in any order. So order is not really important. So y1 and y2, the Wronxian of this will be cosine of 2t sine of 2t. The derivative of cosine is a negative 2 sine of 2t, and derivative of this is a 2 times cosine of 2t. Now, once you simplify this, you're going to get 2 cosine square 2t plus negative sign here, so minus minus plus sine square 2t, which is 1, so your Wronxian is just 2. Now we have the Wronxian and we have also y1 and y2. So in step number 3, and this is our final step, what we will do, we will plug everything into this particular solution formula we have given. So I will denote it by y p of t, or you can denote it to y capital. This doesn't really matter. So this is a minus cosine of 2t, the integration of cosine of 2t or 2s, doesn't really matter which variable you use in the integration. So I will just use 2t times the forcing term, which is a 3 times consecant of t, and whole thing is divided by the Wronxian, which is a 2. This is a dt plus that is going to be a sine of 2t, and this time I will multiply by the cosine. Sorry, that was a sine, not cosine. So this is a sine because you have to multiply by y2, opposite to them, and here will be a cosine of 2t, and that will be multiplied by 3 consecant of t divided by 2 and dt. And therefore, this is equal to minus 3/2 cosine of 2t, and the integration of this sine of 2t is equal to 2 times of sine t cosine of t. I will change it to a single angle, and this is a 1 over sine of t. Cosecant is 1 over sine of t dt. Plus again, this is a 3/2 and sine of 2t. Now the integration, cosine can be written as 1 minus 2 sine square t, and then he'll divide by sine t dt, because 1 cosine is 1 over sine. So if I pull out that 2 also, this will be cancelled. This is a minus 3 cosine of 2t, and this cancel out. The integration of cosine is sine t, and here I have to work a little bit more. 3/2 sine of 2t, integration is 1 over sine, which is a cosecant of t, minus, if I divide sine square divided by sine, it's going to be just sine of t dt. So I also know how to integrate cosecant of t, and then also I have basically the formula of calculating what is a 2 sine of t. So therefore this is equal to minus 3 cosecant of 2t sine of t plus 3/2 sine of 2t, and then I will put the parentheses here. This is going to be, so this is the end of this questions, and we have now the particular solutions. This is our particular solutions of this question. It's a pretty long, complicated particular solutions, but this formula is a quite useful to find the particular solution. Also, you can notice that this function is 3 over sine of t, and the method of undeterminate coefficient cannot be used here to find the particular solution. So the method of method of the variation of parameter is the one of the most successful method to solve a different type of the forcing term for the non-homogeneous differential equation. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Let's solve one more problem using the method of variation. Here we have the differential equation t square y double prime minus 2y is equal to 3t square minus 1. The very first things we would like to do is we would like to clear off the coefficient of y double prime. So this will be a y double prime minus 2 over t square y is equal to 3 t square 1 divided by t square. So in fact, our forcing term is now 3t square minus 1 divided by t square. So these are the two particular solution is given. So we do not have to, in this situation, find the particular solutions because we have given these particular solution. The things we need to do in step number 1 is now find the Wronxian of y1 and y2. So we will do that. So the Wronxian will be t square 1 over t. That will be a 2t, and that will be a minus 1 over t square. This will be, this multiplied by this is a negative 1, and then there will be a minus sign, and that multiplied to this will be just 2. So your Wronxian is a negative 3 in this case. Now let's go ahead and write down the solution, the particular solution y of p, y1 negative sign. So this is a t square integration of y2, which is a 1 over t, time the forcing term, which is a 3t square minus 1 divided by t square, divide by the Wronxian, which is a negative 3 dt, plus y2, which is a 1 over t integration with other term y t square, and this will be multiplied to again the forcing term 3t square minus 1 divided by t square, and whole thing will be divided by the Roxian and dt. The variable of the integrations does not really matter which one you choose. So this one is a minus t square, and if you simplify this, you also negative 3 in the bottom, so and this become positive 3, and then integration become t cube, so 3 t square divided by t cube and minus 1 over t cube dt. Here again minus 1 over 3 t, and integration will this time become 3t square minus 1 dt. So a little bit of simplification here. This is a t square divided by 3, integration of 3 divided by t, or t to the power negative 1, and here is t to the power negative 3 dt minus 3 minus 1 over 3t, and then the integration, you can calculate the integration of this. It's going to be a t to the power 3 minus 1 half t. Sorry, this is just t because it's just a 1, so this is just t. Let's do this integration also. This is a t square divided by 3. If you have 1 over t, it's going to be 3 natural log of t, and this is going to be positive 1 half t to the power negative 2, and then minus 1/3 t and t cube minus t. So this will be your particular solution for this differential equation. This differential equation has variable coefficient. Okay, this is the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.